Okay, starting off, this is Intro to SQL Lite, Intro to SQL workshop done by Stats Club. That's my name up there, Dell Coin. So starting off with basically a quick summary of what SQL is. SQL is a database programming language based around tables, sometimes called relations. Where we have named columns and unnamed rows. So say like select star from example, where example is a table in my database, and comes up to this here. Goes to a table. So go first a little bit into the basic theory, then basically into first basic theory, then how to use it, like how to use the select clause, from clause, and group by statements and all that. Subqueries, set operations. This presentation is be based mostly around doing a query, not setting up a database, so not creating a table or create indexes or anything like that, just how to query a database. So first of all, how we first get the content. Preferably go along with this website here, GitHub, normally same, that's my ID, and Intro SQL. From there, just basically download a zip file, or you could even, if you're on the website, click on that and you should download a zip file. Next, if you have a computer that has SQLite installed, it's preferable to open it up and then open up the statsclub.d file, which is database file, SQLite database file, in the download directory, and click on the SQL execute SQL tab. Show you here. So on this tab here, on this here, open it up, and that there. And so this from here, you could actually just select code and press play, and you could actually see it running. This is why it's nicer to have like SQLite browser with you, so that way you could actually fiddle around with things, play around. Just the nicer way to doing things. So yeah, so open up the SQLite file in the execute SQL. Open up the intro SQL presentation.sql file and follow along. The content is on the wiki, which is right here, also on the board here, present on the board. And then just basically follow along with the browser or through the SQLite browser. So go a little bit with some of the features of the SQLite browser. So you can see the data structure of your database that you already that's loaded up. So say this right here, it shows like, okay, this actually syntax for creating a table. So create table, event, blah, blah, blah. And it has everything available for you. Yeah?
How do we find the stats data from our computer? Is it in the history?
You should have, when I said download zip file.
Oh, it's
that's
in there.
In there. Yeah, it's statsclub.db.
Okay.
Okay. So you can see the data structure. You can also explore the data through the browse data icon. So then you could just select which table you want to look through, and it shows everything up there, like sort of like an Excel sheet, but not quite. You could also execute SQL statements in the execute SQL. So highlight what you want, press select, and press execute, that button right there, the play button, and it'll, if the syntax is right and the database is relevant, it'll load up the table. You could also easily construct tables from files. Like you could create a table from a SCV file, and you could also create tables. You could also modify tables as well. So change from strings to integers or floats. So why learn database language? First of all, database is rarely tidy. Unfortunately, like most stats club, like most stat courses is, you're usually just given data. That's usually not the way you usually get data in industry. So most of the time, data is in a database, like SQL database. That's where most data is, where quite a few data is. So first of all, why learn it? It's one of the most popular data analysis tools. For statisticians, it's pretty much the second language that you would use. So behind R or Python. And it's also one of the most in-demand skills for 2014. Yeah?
Sorry, I'm having trouble downloading the song. Can you hold me for a second?
Sure.
Is it in here?
That's how you get around. Yeah, just open up the data. Anybody have any other questions? Everybody following along so far? Good? Yeah, SQL also could manipulate the data as you want, retrieve data, slice, dice, whichever way you want. Yeah. SQL could also not only receive data, but slice, dice, and transform your data as you see fit. It also, because of the relational database, relational engine, it can be used in ways that it wasn't originally designed to use. So if you were an expert in SQL, you could do Monte Carlo simulations in it. You could do linear regression in it. It looks really weird, but you can do it. So that's one of the things about SQL is very flexible. So what is SQL? It's a programming language allowing multiple concurrent users storing, manipulating, and querying data. One of the nice things also is all the data does not necessarily have to fit into memory. It could spill to disk. So why SQLite? It's quite easy to use, easy to share. So it's just one file. So you don't have to set up a server if you don't want to share data that way. Just one file. Hey, give it to your friend on a USB stick, whatever you want. It's also good language for practice with to learn SQL. Like for instance, if you want to store your data for a Kaggle competition along with multiple other people, just bring it into SQLite and use it. There's various different many implementations, but they all have pretty much very similar syntax. To going from one implementation to another is really easy, but there's some differences. But here's some different implementations of SQL. Versus MySQL, it's highly popular open source. Postgres is really nice that it's very extensible, so it has a lot of add-ons. SQLite is the only one that's mainly for like one user at a time, but it's also very lightweight. So that's the reason why I like pretty much anybody who has a cell phone has SQLite installed. It's pretty much on every cell phone. Every Mac have it already installed. I know Firefox uses SQLite for its background to store all of its data. So Oracle is another implementation done up by Oracle Corporation. There's also Microsoft Server and DB2. I know DB2 is used quite a bit by Waterloo here. So going to relational database. Relational database is a system organized by tables containing records, rows, where it has relations to other tables. Each entity has an attribute, and which give you additional entry information. So it's best to think of each row as a separate entity, some kind of object. And for every column, there's a field or attribute or column. Each are interchangeable, and it stores a little bit of information on that single single entry. So each row is also called record, which is a tuple of columns. A table, also called a relationship, is a collection of rows. Usually in reference to a persistent table. A persistent table is the one stored on memory, on the hard drive. But one nice thing is each SQL query creates another table, which you could chain to other tables and create a that's the meaning behind the relational database. It keeps on creating tables so that you could spin off several tables into one, join them up, manipulate it as much as you want. And result set is actually a non-persistent table. It's the result of a query. So the result of a query can be an entry point for another query into another query. And a view, a virtual view is basically it's like a saved query, but syntactically it looks a lot like a table. So you just basically use it like any other table, but in the background it actually creates that query, creates a result set, and basically brings the result set to that new query, where it changes things as much as you want. Subquery is a query that returns a table to another query. Primary keys, basically a tuple of columns that help you uniquely identify each row in the table. This comes out to be really important as you get more and more tables. Foreign key helps identify a relationship to another table. So, yeah, like this key, foreign key here tells, okay, I'm referencing this primary key over here, and that tells you how the relationship. For instance, students take courses. There could be a table for students and another table for courses, and they could basically reference. Actually, yeah, student should be this one, and course is probably this one. So a student would be taking a course, and that'd be referencing there. So the ER models, entity relationship model. It's basically an analysis tool for relational database. So E is basically the entity. and R is relationship, how each object relates to each other. So for instance, it's best to think of each entity as having properties, or also called attributes. So, for instance, for Stats Club, each event has a name, a type, location, and other materials. Each Stat Club member would have a name, quest ID, an email, and each objects relate to each other through relationships. For instance, Stat Club members attend events, and that's done up through primary keys, through primary and foreign key relationships. Now, ER relationships basically is it can be one-to-one relationship, like for every entry in one table, there's exactly one entry for another, or it could be one-to-many, many-to-one, or many-to-many. So, like one-to-many is basically every object of object A. There's many of object B. Yeah.
Is it possible to draw a real table to explain this?
What?
Is it possible to draw a real table, like an example to explain
Later on, yeah. I'm just basically going through it right now, and there's many. It's not too important. Just basically get an idea of what's behind. And so let's go into the relational algebra. So, like for instance, regular algebra is something like that. There, say that's a formula for relational algebra. For regular algebra, we can manipulate this many different ways. You could bring the x in, or bring the z in, or take x out from both sides, from the first term and the second term. So it could be manipulated several different ways, but have the same meaning. Same way with relational databases. So basically, x would be like one table, y could be another table. It could be changed around so many different ways, and it would basically have different, but would have the exact same result. The reason for the beauty of this is that you could, in mathematical terms, the computer can actually figure out, do various algebra applications to figure out, okay, of all these possible sets that this equation to evaluate to, find out which one's the cheapest and execute that. So for SQL, you don't really need to know about optimization that much. You don't need to preset your query, try to figure out the best way of executing it. It will usually do it up pretty much by itself. There's some edge cases where it's not quite true, but on the whole, you don't really have to worry of how to execute this efficiently. It does it all up on the machine. So basically tell you a little bit what operations it is. Like projection, returns subset, selection basically returns only the rows where some condition is true. Rename, can rename an attribute. You can also join up tables based off of attributes that have the same name. Could also have theta joins or equally joins, where you could basically join up tables based off some condition. So you have join up two tables to bring up to make into one table, and this is basically the operations that the relational database would use, and it will basically do various calculations, figure out which one of all possible, of the most possible possible expressions that your query would relate to, and find out which one's the cheapest to execute, and execute that. So basically, the idea behind this is the SQL basically goes in the background, figures out what's happening, what's the best way of executing this, and executes it based off all these operations, and well, also set operations, which basically joins up two tables like a set. For instance, have the exact same number of attributes and same type for both tables. It joins up by column row-wise. So it's like first column of of one table matches the first column of a second table, and you could join them up like stack on top of each other, or you could even do intersections, differences of two tables. So this is quite powerful as well. So little tiny quiz. What kind of operations performed on these tables? Like for table A, no. What's this one here? No. Yeah. And what's this one here? Yeah. Yeah, and what kind of joins can be formed on tables? Yeah. Oh, probably, yeah, that's it. I probably should say also that you could have like different conditions, so greater than, equal to, and constraints. Constraints limits what can be entered into a table, and helps encapsulation. So helps make sure that everything's working properly. So you can't mistype something and put some kind of weird nonsense into one column that messes up your data. So we could have primary key, which basically to help uniquely identify each record. Then foreign key points to a primary key, and that helps basically helps them join them up together. Check constraints limits the range of values that can enter into a table. Unique constraints enforces uniqueness onto a column. I'm not going to teach you how to create these constraints, just realize these exist. And not null constraints enforces a field to be not null, as in some entries can be put in and have no value. So, in which case that entry would be null. Null is very interesting. I'll go into it later on. So, go into basically the SQL language. For SQL, case does not matter, as in everything could be lowercase, uppercase, somewhere in between, and it'll still go through everything. For presentation purposes, uppercase is used for keywords. So for select star, the select word would be uppercase. That's to show you that that's an SQL word. SQL statements are processed as a whole, so you could have multiple lines for an SQL statement, or it could have one. It will only execute once it's reached that semicolon here. So it ignores white space, new lines, everything until it finds that semicolon there, and then tries executing it. Good. So we'll be using a database based off around Stats Club. So for instance, we're saying for about many to one. There's many Stat Club members attend events. So this is a many-to-many relationship. So many Stat Club members can attend many events, and for every event, for every attendance, there's one event. For like multiple attendance, there's one event. So multiple people can attend one single event. And event has many expenses, so this is many to one. And I think this is also many relationships as well. So you get that basic idea, right?
Quick question. This is
Yeah.
really dumb. When we get the data from the stats club, is it gonna be presented to us as a table, whatever, or
Yeah.
as this?
Well, this is basically to understand in the table that for database there's several different tables. There's the table attendance, table member, table event, table expenses, table exec, and table exec
So we have
position.
a table when we have because I'm confused when you were talking about the structure here.
Yeah, like for instance, event.
Okay, so yeah. That makes
That's one thing here, where it has attributes of type, presenter, organizer, and yeah. But each one, this gives you like sort of overhead view of like where everything's going on. So, for instance, the primary key of event, well, expenses has two primary keys, event and expense. The event is also a foreign key that references event, the name of the event. And so like the attendance, there's a primary key of event and member, where member is also a foreign key that shows up the quest ID for member. So that tells you how to join up tables. So this, I'll be showing this later on, but for questions that kind of need multiple tables. But this basically gives an overhead view of your database. For data types. In SQLite, there's 5 basic data types: integer, real, text, blob, and numeric. Integer is basically signed. Real is just a floating point value. Text is a string. Blob is just basically binary data. So you could potentially have an image put into it. It won't know that it's an image. It just be just storing ones and zeros, and from there you could actually take from that the ones and zeros and convert back to an image. Yeah.
In the previous slide, did you like do a join of sorts?
This one here.
Yeah.
This basically just tells you how to join. If you want to join, if you want to join event and expenses, you basically join up the event name with the event from expenses, and you basically get a new table. This basically tells you the foreign key, so it helps. It's best to think primary keys and foreign keys as what they reference to each other and how they relate to each other. Like for instance, this data can tell you quite a bit of what Stack Club is and what it does. So this is sort of like, think of it as the overhead view of your database that we're going to be using today. Okay. I went through this, right? Yeah. But SQL in general has some general data types. Each implementation is slightly different, but overall they usually have most of them have these data types. Char, which is just a character string of fixed length. Varchar is a character string of variable length. Binary is a binary string, so basically the equivalent of blob for as mentioned earlier. Boolean, which is Boolean values. Variable binary is basically binary string where it has a variable length of a set less than n. There's also integers, where it has a precision, small integer, regular size integer, where it's called integer. And big ints, well, it's higher precision, and also decimal, which which is helpful for monetary transactions. So like, you don't want to go like 3.45679. What the hell does that mean? There's no sense for it. So, and there's also numeric, numeric, so exact numerical precision, floating points, where you define the precision. There's also real numbers, floating points, dates, times, and also timestamps. So timestamps basically, if you create a query, insert data into a table, it actually, for that timestamp in that area, it'll actually timestamp the current date and time. Second, null values. This is basically the necessary evil of SQL. This can mess things up quite considerably. Any data type by default can have null values. A null value can be thought of as an unknown. In fact, there's quite a few implementations of SQL and several different people that considers it an unknown. It just, if, for instance, I'm taking CS 338 right now, he actually prefers unknown rather than null. So everybody understand that? So you can think of null as unknown, or some people prefer just, okay, consider this unknown. So say if x or y is null here, So if we have an x value, so let's say an integer, 2 plus a null will give a null. If you also do a comparison with where it has one null value in there, it will also return null. So this propagates pretty quickly. So you have to be very careful with this. So SQL uses a 3-value logic system: true, false, and null. So true and true gives you always true. True and false gives you false. True and null, or think of it true as an or and unknown, you don't know. So you have to go with null. So if something is true and we don't know, the result would be we don't know. And so, and for nulls, basically, so for null and something, we'll always, if it's the other one's true, it'll be null. If it's false, that will give us false, because we know that's false. It's also different from or. So a null and a false, null or false, you don't know. So it gives you back null or unknown. And
Would you explain the first table again?
okay, so true and true, that's true. True and false, that's false. Like a regular table.
So I read like this: false and false.
Yeah. True and true, true and false, true and null, or true and true. So basically, true and null will always give you null. True or false, false or null will give you a null value, and of course, null and null, or null or null will give you null. So it's best to think of it as unknown in this kind of cases. So say something is true, and something and the connection is an and, a no value. We don't know the result of that. So that would result in a null value right here.
And what would be the logics of false and null would get a false?
Say again?
What would be the logics of if you get a false and null? we end up getting
false
instead
and
of
false and null. So something, the connective is an and, so it's only true and something else. So if we have some true and we don't know, like something we don't know, then the result is something that we don't know, which would result to be a null.
Okay.
Good? And our, yep,
I think the question would be false and null. Why is it false?
false and null?
Yes. Why is it false instead of
Well, because false and anything else will always give you false. So even if we don't know the other ones, it has to be false. So
How about false or null? Why are we talking null?
okay, so false or well, first of all, true or null will give you true because true and any or anything else will always give you back true. But however, for false and or something else, if that something else is true, then the result was true. If it's false, then the result is false. So we don't know. So we would have to basically say unknown or null. And true, not true gives you false, not false gives you true, and not null gives you null. Just saying something, I want the inverse, I want the opposite of an unknown. You don't know. So it could be true or false. So it could be the result could be false or true. You don't know. Anything else? Yeah, this is the kind of tricky situation. So you have to think of it sometimes. Everybody get it? Best to think null and unknown basically meaning the same thing. Do you guys want to take a little break now? Basically stretch your legs. 10-minute break. Come back at, yeah, we're here for over an hour, so come back in 1:10. Good?
It's a big question.
Yeah, especially it's like probably over by 5.
Maybe this thing.
Yeah, I don't have my. Well, I have a recording. But that's it.
Is it inside of the water or the
Some. That's 4 o'clock. So basically 4 o'clock. I think there's your beef. No, I don't know. Okay, and no drinks. If we have drinks with it.
Yeah, so I'm like, I was like, like a vacation. So this is your first language? Oh, wow. That's a big data. Yeah, I think
The answer. Oh, okay. That's so easy.
because I used when I had my whole thing. Because I read so and now you're
But you know, I really kind of like. Yes, but we have a lot of super computers. And in my job, I feel like because I just think this
How are you? Yeah, I know. Like, hi, am I white? How do you want to know? Why the fuck do I want to tell you how I know? I did okay. I'm not like stellar. Next week? Like right now, basically touch on, various standard deviations. Everything would just so hard.
Everyone back? Everyone back? Good? Any questions? Just to warn you, not supposed to have food in here. So just, I won't narc on you, but still, don't have food in here.
Oh, I ate outside.
Yeah, drinks too.
Oh, water?
Yeah, because it might spill and might short something out. So just, yeah. If you're going to eat something or drink, stay up away from the computer for a bit and then go back. Yeah, and throw things out. Yeah. So, it's not like I'm going to report you, but still, don't. if they find out, we get stink. So go on to projection. So this is basically a select clause. This is the kind of the brunt of what querying is about. So it returns a set of tables. Returns a table with a value, with a table of values. Sometimes the table is empty, whereas this, where we specified what we want in the statement. So in the select part of the clause, we select the columns of our result set. So if we want to column 1, column 2 from some table, we actually select our columns with a comma in between. Could also, if we want to specify all of the columns from table, then we just say select star. That's basically saying every attribute from that table. If we leave out the from table part, we're basically taking from an empty table. So say if we could have like expressions in our select statement, and if we leave out the from table, it'll just compute the result of that expression. So in the select clause, we could have literals, strings, expressions, functions. You could even have user-defined functions. Literals are basically strings or numbers. And expressions are basically expressions of the columns and literals. So if you just have a literal expression, for every row, it would just have that the result of that expression. So if you have type 1 divided by 2, you just get the result of that for every row that you have that your table results in. For expressions, we basically, for each row, it will change it basically. It would have that attribute into that expression and calculate results for every row. Functions, there's many different functions in SQL, and like for instance, you round numbers, round a float to some integer. You can cast attributes of different data types. So let's go into some literals. So try to calculate 1 divided by 2. So if we just say, 1 will definitely give us, since we left out the from clause, is coming from an empty table, and just saying 1, 1, 2, 2, and a string. And notice that 1 divided by 2 gives you 0. This is basically because it's integer division, so it's truncated. So 1 divided by 2 is a half, truncated to integers, that's 0. If you want to change that, you have to basically have one of them as a float. So same thing here we had, but if we, like say 4 divided by 2 gives us 2, like what we expect, and 5 divided by 2 gives us, unfortunately, back to the integer division. But if we divide 1 divided by a floating point of 2, gives us a half. Yes?
So with this select system, well, select construct like these, we're not specifying, like looking at data from a table anymore. It's actually creating a table with the data.
Yeah. So usually you don't use it very much, but this is basically helpful for illustrative purposes of like why one thing goes, why integer division gives you 0, and once you put in a float inside, gives you a half. So that 1 divided by 2 dot, make sure that 2 is a floating point number. So it's 1 divided by 2 floating point gives you a floating point, which is a half. And you even cast. So if you do like cast 2 as a float, it'll return 2 as a floating point number, and 1 divided by 2 floating point gives you half right here. Good? Is my voice good enough? Or
Can get it if you want.
okay, I'll try. Remind me when it goes softer. Yeah, remember that SQL ignores white spaces and new lines, so it's only ever processed once it reaches that semicolon. So until that point, it won't check anything, won't do anything until it reaches that point, in which case then it brings into relational optimizer, figures out what's the best way of executing this, and then execute it. So the following two statements produce the same results, say 1, 2, string, and we have a whole bunch of white space here, new lines, a lot of places, get the exact same table. So white space and new lines, it doesn't register them. So basically what you use for white space and new lines for is to make the code more readable. But it won't change anything, won't change the result in any way. Just that, for instance, if readable form is, say, if some query is like 100 lines long, you don't want to shorten up into one line because it's almost impossible to figure out what's happening. So, going to some SQL functions. There's many of them in SQLite. There's also many others in other implementations. So for instance, if we do absolute of a numeric column, we'll remove the negative sign. Length of a column returns the length of a string for each row, for each record of that string column. And lower, basically for a string, brings it all lowercase. Upper brings the columns entries into uppercase. And we can even have random numbers. So if we have random in here, we get a pseudo-random number between these two values, which is binary, and so yeah, that's done for each column. Done for each row or record inside that column. So select absolute of -8 gives us 8. Length of this is a string gives us 16. Lowercase brings everything to lowercase, and we could even have a random number here. There's also many other core functions. So if you just want to go on the website, some SQLite website, they document quite a bit. Each has its own, and there's even more for SQL, other implementations of SQL like MySQL and Postgres. Postgres could do a lot more extensions, so you could have almost any kind of functionality you want. Yeah, so do a little quiz. Calculate the average of two random numbers. So basically create two random numbers and find the average of them. Remember get a random number by the function random. If you don't have a SQLite browser on you, just try to figure it out, or or basically follow along with somebody that has it. Yeah, if you want to, if you go into a terminal, actually, if you really want to, you could do SQLite 3. And that brings up SQLite.
Same format like
What? Yeah, you could do some stuff in there. It's like it just.
Like executing a command.
Yeah, you could execute a query, but you don't. If you go into the directory that you. If you go to your if you go to exactly which the directory that you have the database file in and SQLite 3, so Stats Club DB, that would basically like star from exec. That gives you that. It's not nowhere near as nice as SQLite the browser, but if you just want to check a few things out, this is a good way of doing it. SQL is already pre-installed on every Mac, so unfortunately it doesn't seem to be the browser seems to be uninstalled. So this is a good way of. Yeah, June. Have any questions? Raise your hand. Yeah. Oh, that's only for people that don't have SQL browser. That's another way. If you get it from Mac, from MacBook here, it's nowhere near as pretty as the browser. So this is the best one. Yeah. Browser is better.
We met. That window there, I only showed it to you so that the people that don't have SQL-like browser, you could potentially use something. SQL-like browser is much, much better.
She goes to grad. She's in grad school now. So basically, she's doing data analytics. And part of the requirement is they have to be SAS certified. I think that's pretty good. Because that everybody uses it. It's okay. So which is pretty limited. And I didn't even put the like I saw the hardest thing.
I only had open the terminal for people that don't have the browser. So if you don't have, if you have the browser, use that. It's much better. It's much easier to use. It's nicer. Good.
Yeah. Yeah, just as a reminder for you guys, so once you open up the database, here, you could execute SQL queries right here. So select and once you could write things up there, select them and highlight it, and just press on to execute here, and it gives you a table. And also, if you want to increase your font size, this here, which makes it a bit more legible sometimes. What? Oh. For,
How do you change the font?
I change the font. Go to Preferences, and then go to SQL, then Font Size, SQL Editor font size, SQL Log font size.
We don't have that tab in like the Microsoft.
Oh, and I'm not sure where it is in Microsoft. So, and if you want to follow along, and if you want to follow along, just in the Execute tab, this right here, this opens up a SQL file, allows you, so you can open up .sql, which is basically just a text file, but with SQL queries in there. So open up the intro SQL presentation, and this has all the examples that I'll be doing. So you could follow along as I'm doing things. You could also modify as you wish. So you could figure out, oh, if I change this, what will this happen? How will this happen?
How do you create a new file?
For what?
Just a thing.
Oh, create a new file? Well, you could also create a new thing here, and you could then save it as whatever you want. So is everybody done with this? Good? Okay, so basically select two random numbers, and we put it inside the brackets and divide by 2. I made sure it's a floating point, just ensure that I will get a floating point at the end. Yeah, and so what is the upper and lower case for the string upper or lower? Remember the function before of lower, return string in lowercase, upper, return string in uppercase. So if you have any questions, raise your hand. It's pretty similar to what we just did, so. This here is the string I was talking about. With the single quotes, upper or lower. Strings are inside of either a double quote or a single quote. Yep. Where's your slides? Yes. I'm not sure if you want to say one, right? If you want to say one. I'll go with two separate words. Here's just one single word. Anyone else? Everybody finished? Good. So select upper, where we have that string in there, and comma for a new column. Lower, and we have basically lower of that string. So from clause, this basically specifies where we're getting data from. Usually a table, or it could even be joins of tables, or more elaborate queries or subqueries. But this is basically where we get our data. So specify the table, either persistent or a result set, and we could even join up tables. So for instance, what are the names, types, times, locations for Stat Club events? So I select name, type, start time, end time, and location from event. Give us all this information right here. The ordering, just for you to note, the ordering is not crucial until you actually specify ordering. So each implementation of SQL could potentially have a different arrangement of which is done first, where each event is. So it's best to think of like BOT as some event being in the entries or the rows here. Everybody understand this? Good? Yeah?
The type won't be like highlighted green.
Why is it green?
No, it won't highlight green.
That doesn't matter. that actually shouldn't be green because it's supposed to be a column. But yeah.
So when you select name, it just produces like you can't just select the exact cell within the table. It just produces every name within the column.
Yeah. What you're saying before, like that exact name, you could do that in the where clause, which get to later on. But right now, we can't really take away any rows. That would be selects. That would be like the equivalent of a select. What we were talking before, operation. Yeah, we're not into that yet. So this only basically projection, or in this here. So we're projecting name, type, start time, end time, and location from that table. Yep.
So you do some sort of like can you create a column saying time is start time, end time is start time or something?
Yeah. Like,
From this?
can you create?
Can you create you can just add a column to this thing, time is end time and start time in select statement?
Yeah.
Duration is end time and start time.
Yeah. You can do that. You can basically just take away one from another. It's best to do it when you have a data type, when you have a date time data type, because it does it up all nice and pretty for you. SQLite browser, however, doesn't have a date time data type, so you would have to basically use one of the functions to say, okay, convert this to basically a start time date, and same thing with this. Take away the two, and it would find the exact duration. But so you can recover that information from here. SQLite doesn't have the best way of doing it, but like for instance, MySQL can, if you have it set, done up in a date time type, take away the two, give you the duration. Yep. Anything else? Yep.
For the command, you would have to write in uppercase.
No. As I said before, the case does not matter. So the select and from, I only have that as uppercase to emphasize that this is part of the SQL syntax. So Otherwise, that doesn't really matter. Yep.
It's my son now. If I select something, the name does not exist in the file event, will they still show up something or show up
So if
error?
it doesn't say if this here, if there was no name, data type, what would happen?
Yeah.
Well, could just check it out yourself, but
Sorry, I don't have.
yeah. So right here, say, and I think that we should just basically say there's an error. See, no
So it
table.
wouldn't even run at all.
Yeah, because there's no column. Type that.
Okay.
So it'll just say, oh, there's an error. I don't know what the hell you're talking about.
Okay. Thanks.
No problem. Yep.
I know other clients allow automatic capitalization of keywords, so does SQLite does it have anything like that? Like I don't want to
I
have to
don't
log
know.
every time.
Well, you don't have to.
Yeah.
It's as I said before, it doesn't really care about uppercase or lowercase. It just runs it. So if you're doing it for yourself, I always just do lowercase.
Yeah.
It's only for readability purposes that have uppercase.
All right.
Like, so if you're just doing something for yourself, like,
Okay.
that's what I do. If I'm making a query for just myself, lowercase, because why? Why else would you do it? Anybody else? Everybody understand this? Good? Okay. So, a little quiz from the phone clause. Who are the execs for Stats Club? What are positions and emails? So we're doing projection of name, position, and email from the table exec. If you have any questions, raise your hand. Yeah, I know.
It's weird. When you select and select where. So you don't have to select keyboard, select where.
No, your selection is select. From some table where some condition. So you have to. So you George always use it. If you're doing a query, you have to use it. Any questions? How are you guys doing? Good? Go on? Okay, so select name, position, email from exec will give us all these names here, all these positions, and emails. All the data here is pretty much fake, so don't have to worry too much. I do have my information on here, but that's it. So everybody understand that? So we project name, position, email from the exec table. And so select name, position, email from exec, and gives us here. Remember, there's in a query, you always need a select statement. I need the select clause in there. If you're doing a query, if you're doing something else, then it'd be a different kind of statement. But for any kind of query, you need that select statement. If you're getting any data from a table, you need a from clause at some point. Aggregate functions. So these take in columns of a table and aggregates over the entries. So, for instance, average of a column will give you the mean of that column if it's numeric. Count basically counts the non-null values of a column, or it could be even a set of columns. So if you usually do count star, where it basically counts the number of entries or rows. Max, find the maximum values of that column. And minimum, takes minimum value, could even sum up values of a column. And group concatenate is basically concatenate all strings together. So there's also other implementations of SQL that have more aggregate functions. So for instance, we count, select count 12, and that will, since it's only considered one row, it's 1. Same thing with the string, just give us 1. But if we have a null value, there's nothing that, it doesn't count it, so it's 0. Sum of one value is just that one value. Sum of one value, just that value again. However, sum of a null value, it doesn't consider that a value, so it just ignores it, and we end up with a null value. And yeah, average of 0 gives us the average, which is 0, and since all the columns, which is 1 here, if we take the average of a null value, we get nothing back, so it's null. So, for instance, next we're going to start with this little example table here. So, this is a string which has each entry. This is a string concatenated. We're going to concatenate that later on, which has various. This one has various floating point numbers. This one has various numbers. So if we do select count star, we give basically 5 entries, and we basically count each one. Notice that as long as there's some row, there's something in one of the columns here, it will register, okay, there's something there, so it finds that. So it still counts that in that count. But if we do like count of just the floating, which has one null value right here, it will only count up to 4. If we do a string, 5. If we do the average, gives us what we want. We'll just do the average of these values here. Sum gives us the sum of all these. And if we do a group concatenation, we concatenate the string to this is string concatenated. Everybody understand? Any questions? Go on. Yeah.
So when you select count star, it's just counting all the columns, right?
Counts the rows where, basically, since there's no row with all null values, it counts that it counts each row. But if you just had like a column there which had a null value in there, like count of floating, we'll ignore that null value and not include that in the count. So, for instance, here when we had 4, counting of so we did counting a float, gives us 4, because there's 4 that are non-null. But if we do a count of star or a string, since there's something on each row in some column, it will count that. Any other questions? Good. Distinct. This basically removes any kind of duplicates of our columns. So we select distinct from, and then we specify our columns from our data. This basically eliminates any kind of duplicates. If you can avoid it, it's best to avoid distinct because when you use distinct, it'll try first sorting it, then applying unique to each, like finding out if there's any unique one, finding any duplicates and just removing that duplicate, so it only keeps up with unique values. So if you can avoid using distinct, it's best to, but sometimes you need to. So and you could even use distinct in select statement at the right after select or within functions, aggregate functions. So you'd use select some aggregate function, then distinct of some column, and that would basically only give you the values that are distinct. So only use that aggregate function on those values that are distinct. And so, like for instance, what events have members attended? Or distinct events where where at least one member attended. So we select distinct event from attendance. Since there's each one has at least one sort of in each event that already happened, there's already one person, at least one person attended. So in which case that would appear. But if there was no attendant, if the event didn't happen yet, there is no attendance, so it's not in the table, it will completely avoid that. So it will, but in the attendance table, as I'll show you here, So attendance, see there's, for each event, there's many people that go to each one. So if we just left away the distinct. So like for instance here, we get distinct, but if we take that out, we get all of them, get all these duplicates. Everybody understand that? And yeah, so, and remember that you could use distinct within aggregate functions as well. So, so let's go into this for quiz. What are the distinct majors of stack cloud members? If you have any questions, raise your hand. Yeah.
But they were not.
Yeah, we have to take a table and insert data into it. And
Everyone done? Good? Any questions? Okay, go on. So if we select distinct major from members, we get stats, pure math, CS, no duplicates at all. So it just basically takes away distinct, takes away for major, finds just one, eliminates all the duplicates for each one, and gives us this kind of table. So how many distinct majors of Stack Club members are there? So we basically, in this, remember using in a count function. So remember you can use distinct inside aggregate functions. Count is an aggregate function. So try and see if you could figure out how to use distinct in aggregate function. Yeah. Remember that distinct can be used inside of aggregate functions. So if you want, count is another way of counting how many. So use distinct within count. That's the key for this, okay? Any questions? How's the pace going on for everybody? And going too slow, too fast? Sorry? Okay.
Yeah. Selecting from should
So you had to put a big point. So you think one machines that distribute yourself. I can do this machine.
Yeah.
So yeah, you're doing
It's like a chop.
So everybody good? Okay, so select count, and we have distinct major. This inside here basically removes any duplicates of major in here inside, and then we basically do a count. So from the member table, in which case returns 7. Aliases, we could actually rename our columns. This is usually helpful for readability purposes and as well as helping with result set. So basically we select our column where we have the syntax as our new name from our table. So it makes the final table more readable and also helps with subqueries that helps with subqueries, so that you from that subquery you could specify certain columns to do other operations. So this is really helpful. So remember, as renames the column. Technically, you don't need to have that column as long as you have the space there. It will interpret it as having an as in there, but as helps read understand the query a bit better. So say if we want to give column names aliases for a previous table where we had count as number of rows from table example, count star from as number of rows, count string as number of strings, count float as number of float, average number as average number, sum of a number is sum of integers, concatenate our string, where the comma and space basically says between each one add a space, where we call it now as cat string from our example table. And as you can see here, it actually specifies here a lot more legibly than just repeating the function. Any questions?
Is
Yeah.
it possible to change that number 0 to 1?
That there is just because of pandas.
Oh, okay.
I'm actually wrote this up in Python,
Oh.
and I'm actually hiding Python right here. And this is part of pandas.
Okay.
So do you use the same syntax in Python?
Basically, you have the syntax as a string inside of Python, and you just basically specify, okay, this is a string I want to execute in SQL, and it goes through the connection, executes it, brings the information back, and I'll show later on basically
Okay.
through pandas, and actually makes it up a little nicer. Yeah. Yeah. Later on, I made a little tiny presentation on how to use Python for SQL, but this is basically how it tells you how to make that query string. Yep. No? Okay. Any questions? Good. We could also create aliases for our tables. This is really helpful for when we're joining tables, so that makes things more readable and understandable, and helps when we do extra queries. So, say if we want to do table, if we do select table alias dot column name, we could have multiple column names like from different tables, and we could just specify so some alias dot our column in that table, and it will understand which one we're referencing. The table alias, usually it's just a lot shorter than this, but this helps identify where you're getting from which and where. So the dot, just remember that basically specifies, okay, inside this column, beside this table, there's this column. We want it right here, and etc., etc. And we specify our table aliases right after we specify the table as this here, and so on for each table. And this, as I said, really useful when we have tables with common column names. Yeah, and basically we reference the column by table name dot column name. So in the select, now onto the select clause. This basically filters the result set, removing rows and where some condition is true, or where some conditions are as false or null. So this is basically the equivalent of selection, what we had before in our theory part. So, like what Stack Club events are social? When we do select star from event, where type equals social, we eliminate all the non-social events, all the educational events.
So it's like a filter.
Yeah, it's a filter. Selection is the equivalent of where we had, in our theory part where we had selection, that's equivalent to a filter, where we select only rows. This basically is the equivalent. Inside the where clause, we could have various different predicate operators. like for instance, if some column name is equal to some value, so like, or gender equals M, or male, or whatever, or female. There's also not equals to, where same thing, like, so not equal to some value, greater than, where some value is greater than. Strings also can be used in comparison too. So same thing with date, times, all that kind of stuff. You could do comparisons. So like you could do a comparison of like some string, like a name, against another name, and it does it alphabetically and figures out if which one's greater than or equal to, and less than, same thing, equivalent, greater than equal to, less than equal to. You could also, if you want to check for null values, either check for is null, not equal to null. This is really important because nothing is ever equal to null. It only is null or not null. In which case, we just check for is null or is not null. You could also check between, so like where some number is between 3 and 5. So it will only bring up those those rows where some column is between 3 and 5. In, where it has list of values, so where some column number is in a set of values. So we could have some the column num in is either, it will only return like 3, 5, and 8. Also, we have a like, which is a search pattern. I think it's a very, very weak regular expression, if you ever heard of that. So there's only two operations for in the like operator. Exists, where some query has some rows, so where exists and subquery, if that subquery returns no rows, it will basically return false and eliminate that kind of row from the result set. The like operator has two basic characters inside of it. The underscore basically means character of any type, so of one of any type. And the $sign means 0 or many characters of any data type. So, for instance, some members start with F. We select star from member, where name, like, F, %, basically gives us only the values where they start off with an F. Everyone understand? So what's for one character in like predicate? What symbolizes only one character? And what about 0 or more? Yeah. And there's also operator modifiers, so all, any, or some. So we could have operators like equal to, when it has something that's equal to or not equal to. We could also inject something into a list of values. So unfortunately, SQLite doesn't have any of these, but so it basically checks to see if that operation, that predicate, is true for anything in that the list of values. If it says any, basically turns true if any of those values is in there. And if all, basically saying that it only returns true if it's true for all of the set of values. So say select star from some table where a column name is less than all of, where we have some subquery, and this basically says, okay, the subquery returning only one only one column. This basically gives us a list of tuple values to basically check against, and it will check through all of them, see if there's if all of them come out true, then we could have that column in there. Otherwise, we eliminate from that column, that entry of that row from our result set. Everybody understand that? Any questions? These are a little bit harder to digest, but yeah.
So you specify where, like, in brackets there, what exactly are you?
In the brackets there, that's going to be a subquery, which we get to later on, but
Do you have it?
Off the top of my head, I'm not sure, but like, depends on what you want to do. And so if you want to basically do some comparison to some set of values, which you don't know, you have to basically create a query to figure out those values. That's where you do the subquery, where you find out those values. Then when you get that list of values, then it'll be do comparison there, and then make sure that that operation is true for all of them, and then only select those rows from the result set where that condition is true. So usually you don't know the set of values that you're checking against yet, but the other query, the subquery here, is getting that information for you. So this could be done, the all here could be any or some, and it would change the meaning. Yeah?
So the all function gives you a true, right?
It's only true if
Return true, right?
it will only return true if this column, if that row of that column is true for every single entry in that subquery.
Oh.
So say that's the result of 1. That's the result of, like, that's the result of this this one here against one entry of the subquery. That's the second entry of the subquery, third entry, and so on. If all of these are true, then it'll return true. Otherwise, it'll return false. And the opposite here, if any one of these return true, then with any, if any of these return true, then it will turn true for this operation right here, the where, and we'll include that column inside. Include that row. Yeah.
So, does it compare every column to every other column, or is it just sort of like one to one?
No, is it each row to the corresponding row?
Yeah. Or does
Yeah.
it compare them?
Well,
It
it's
does compare
basically it would check for each row at a time. So in that column, it would check first. Say this is a list of the values I return from subquery. First, to check for in the first row, check all through all of them, return. Okay, is this true or not? And then basically include it if it's if it's true. Otherwise, say no, and then go to the second one, check all of them. Third one, check all of them, and so on.
Yeah.
Good? Okay. So what are the expenses for non-social events? So like here's an example here. So what are expenses for non-social events? Remember that all, any, or some is unfortunately not implemented in SQLite. In other versions, it is implemented, like for instance MySQL. So this basically, this subquery here just gives the information into what events are social. So just basically returns a query of everything that's social, all the names that are all event names that are social, and then basically checks through all of them, and basically says, okay, is this event not social? Is this not equal to any of the events in here? And goes through them. If it's true, then it will turn true for this clause, included in here. So doesn't have any, for instance, all of these are non-social events. Yeah, this was made up when I was originally had SQLite, this whole talk, and broken into 2 parts, but found not many people went to the second one because it's hard to arrange time, so that's why it's on the weekend now. But everybody see where this is coming from? So we basically get the event name of all events that are not that are social, and compare them with their event and expenses, and see whether they're not equal. Good? Now, we could also chain operations, like conditions. So we could have where clauses that are quite intricate with an and or operator. So we could have various different set of conditions chained up together. So, and where brackets basically means this is more imperative than other. So where some condition and another condition, then we can chain another or condition onto it and create some some complex queries. So what stack club members have a name that with its second letter is A or ends in B? So if we select from member where name, like, or second letter, that means one character, second letter is A, with percent sign, basically a number of characters, or where name, like, a number of characters, and ends with B. So in which case, gets up this, brings up this table here, where, as you can see, pretty much A, no A here, but a B at the very end, another A. So, question for you. What events for Stats Club are introductory talks? Introductory talks starts with intro.
So you only want the name?
Yeah. Well, anything that includes a name, but yeah, name preferably, yeah.
What, columns? Name columns? Or every column?
Whichever you want. Go wild. Do you guys want to take a break after this? Or continue on? What's your guys' feelings? Do you guys want to take a break after this little quiz, or okay? Just continue on. Yeah.
It's same code.
Still, you see your
It looks like he's trying to pick this as a whole string. So, oh, you had two with single quotes instead of two documents. So we put strings there. So it was thinking your doubles, your two single, like I said, one string here and one string. So here it's oh, remember that this here? This, as I said several times, the SQL Lite doesn't have it inside of the SQL Lite does not have you can't use it. Well, give us a
Any questions? Is everyone done or need some more time?
Percent is like as, so it says as long as it starts with insurance, it doesn't matter what percent is
I know, and then the
Is everybody done, or? How's everybody? Good? Go on? Okay. So select name from event, where name is like intro, and then should have a $sign at the very end. Will give us this here. So gives us intro to Hadoop, SQL, and this is because the advanced and basic is just a reflection of like doing it before, where we broke it up to more places. But yeah, so now what Stat Club members have the first name starting with a letter between A and G? Remember the predicate between? So we could use the predicate between. Yeah. How's everybody? Done or? Okay. Any questions? Okay.
Where name or maybe because I use small letters.
Any other questions? Everyone done? No? What? Yeah. Yeah, because it goes alphabetically. So G is basically the start. I think this.
Same like the beginning is inclusive and the last part is exclusive.
Well, thing is, this is not regular. So like, there's A, capital A, then a capital A, and some, let's say A, smaller k. So that there's no member just called A. There's no member just called G. Yeah.
Oh, here we go. No?
Yeah.
Well, for me, it's much more.
But like people do like
Oh,
common from
Binary blank. So you would say I just think of yeah, that's he's thinking alpha.
Yeah. No, that's only for that's only for like operator. That is the whole thing. To basically do it only with last name, first you need to break up the string into two parts. That would be. It's in a function that I don't know offhand, but I believe it's there. To basically split it up probably by space, and then now you have two columns. Now you yeah. No problem. Good. Is everybody done? Okay. So select names from a member where name is between A and G. And member with their and in between, and you don't really need round brackets here. So it basically brings up every. So it wouldn't include anybody with G name because GA is actually below G, so it wouldn't include it wouldn't include anybody with the first letter G. So gives us all these. Next, group by clause. This is basically how to. This basically groups the table by certain column values and applies the function to each group. So it breaks up first our table here into to various sections into where some where each column has some value, then groups it by this. So it groups up to there, and when we apply a aggregate function onto it, it will only do that aggregate function on that group. In the select portion of our statement, we can only list the group columns and aggregate functions in the group by statement. So if we're grouping by name, we can only ever specify name and something else, and name and some aggregate function on our name. So if you add other columns in there, it wouldn't understand what you're talking about because there's multiple entries for a certain column to basically aggregate on, well, the group by just has releasing one. So for syntax, we select column 1. Notice that it's in the group by column here. Column 2, and whichever one has to be if we select our column here, it has to be in a group by clause, and then we can have aggregate functions on those values. In the from clause, right here. Remember the orderings matters, so you do select from, and if there's a where right here, then a group by. So as remember aggregate functions, now instead of returning only one row, now we could group, we could do a group, split it up into groups, and do aggregations on those groups. So as I said before, we could have average, count, max, min, sum, and group concatenate. There's also more more functions available for other implementations of SQL. So the number of each type of event for Stats Club. There's basically only 2 types. So select type and count star as number of events, so that way it makes it more readable. From event, group by our type column. So there's educational, and we have 6 events. Social, there's 2. Having clauses, basically very much like where clause, but we can have aggregate functions inside of it. So, basically we have, we could basically filter out by aggregate functions. Otherwise, where and having is pretty much exactly the same. So, like how many members of Stat Club in each major, where the major has at least 2 members. So if we select our faculty in major and count star from member, we're grouped by faculty and major, having a count of each one greater than or equal to 2. We get basically math, XI, 10, blah, blah, blah. So everybody understand this? Make sure that the select and group by have, if it's in a select clause, it has to be in the group by clause. And then we can have aggregate functions on those on items we group by. So for each group, we get return 1 row. Everybody understand this? Good? Yep.
How does it go in majors?
Well, because it basically, for each column, each tuple of faculty and major that's in there, it'll only group up on that. So if there was if you just do it by faculty, then it'll group by faculty, and also if you do it by major, it groups up by major. Any other questions?
I'm sorry, what are you counting? Here?
Yeah, I'm doing count.
The count of what?
Number of rows for each group.
Okay.
Any other questions? Number of rows for each combination that you have. That's not, yeah. For each one, not for each possible one, but each one that's available in data. Yeah.
What does the star do?
The star basically says is basically the equivalent of, I'll include all of the rows. Sorry, all the columns. So if you didn't have star, if you said instead say faculties, comma major, then it'll just check on that. But otherwise, you could also have like count of major, and it'll just, if there's any kind of null value in major, then it'll just ignore that count for the count. Yeah.
What if you don't apply group by?
What?
What if you don't apply the group by? What will
Yeah.
we return?
Well, then it'd be giving up an error right here, whereas having. Well, actually, it does. I believe it would. There's always implicit group by for the whole table. So, in which case, if the counts, if the membership was greater than was less than 2, then it will turn in nothing. Otherwise, it will return just the count of number of members.
What if you just have select faculty, major, count from member?
Then it just basically count the number. Actually, double check that. Yeah, it does the count, and for any kind of value there, it'll just return the first one.
Oh.
So the first one it comes across, which would be math and stats. But if it could potentially been math and XI, or another one column that was it there. It just grabs the first one. It's like, I don't know what else you want in here, so dump that.
Thank you.
No problem. Any other questions? So next is group by with roll up or queue. This is really nice for, say, if you want to do in a report. This basically for each layer of the group by clause, it does a total for each layer. So, for instance, it would be do a group by for faculty and major, then just do a group by for faculty, then a group by for then aggregate for everything. So, unfortunately, it's not implemented in SQLite, but it's really useful sometimes. So this is syntax. Select column name, argue function, group by, as we had before, but at the very end with roll up. And so, like for instance, say we wanted, what's the number of stack row members in each faculty and major, include subtotals. So what we had before, but instead we included with roll up. Now it basically says art, econ, there's one member, then it goes down to art, major, none basically says this is total, so there's one arts. So it does that for every one here. Then when it finds it for math, this is the total for math. And then there's the total for everybody altogether.
I copied this and I'm getting a syntax error.
What?
I'm getting a syntax error.
Because with rollup, it's not implemented in SQLite. To actually make up this table, I did some fishing around. Not that I know of. To make up this table, I basically made a more complicated query that joins up on weird kind of conditions. But it works. So. But say if you went with MySQL, this would work fine and come out to something like this. This is the reason why it's not in the example SQL sheet. So you can't really execute it because it just gives you an error. Everyone understand? Any questions? Good. So, little quiz. What's the attendance for each Stack Club event? Yeah.
First it does it for, let's say, notes, and we count, so the front week, it was down, so one. And then for our faculty, our faculty, all of these numbers up here comes out to be 53. And we add all of them together, all faculties would be 34 numbers. So it's like So it doesn't, SQL doesn't really understand what that actually means. So it just thinks that's a string. It doesn't think probably the first one and last one. So that's the reason why it's, if my system letter was an A, I would not make it.
Any questions? Any questions? Or is everybody done? No? Wait a bit. Is everyone done, or any questions? Good? Okay, going on. So select event, and then we count star as attendance from the attendance table, and we'll regroup by our event. So for BOT, attendance 12, we had 12 members that specified that, and that's also specified as being in the event, being the BOT. So this gives us all of our count. Next, talk about joins. Sometimes we need information from multiple tables, so we need to group these, need to join these up in some way. We could do this with cross join, where we have Cartesian products. So every row of one column of one table has the corresponding additional columns of every single other row. So we would have, say we have a table with m rows and another table with n rows. When we do a cross product, we would have a table with m times n rows. So for each row on one table, there's every other possible combination of the other table. Good. Inner join, where we're basically joining on some join predicate. This is basically a thing theta join, but in this one, if we're inner join, we're basically losing rows where the join predicate returns null. So if there's any kind of time when there's a null value in our join predicate, it would just not include that. So, yeah, but however, on contrast inner join, basically we could chain rows from certain tables. So if we do have a left inner join, we basically keep all the rows from the left-hand side table, and in which case, if there's no corresponding match, it just returns null for those columns. The right inner join, basically keep all the rows for the right-hand side table, in which case, keep all the rows from the right-hand side table, even when the join predicate returns null. And full inner join, we basically keep all rows for all tables. Natural join, we basically rarely ever should you ever use this, but this is basically joining based off the two tables have the exact same column or attribute name and same type. So otherwise, this one doesn't work very well. It's also best to actually do one of the other joins because it's be much more explicit, and it's hard to tell like what you mean by the natural join. So say cross join. So do select column names from table, cross join table our second table. So as I said, the result set should have n times n rows. Could also get a cross join by listing the tables separated by a comma. So in which case, if we just from table, comma, table 2, we do cross join between the two, and we get a Cartesian product of them. Suppose we're creating a games tournament between for all Stack Club members, where each member plays against another member only once. We can create this table here. Select m1.name as player 1, m2.name as player 2. We're actually joining up the member table to the other table. However, because of this, for instance, myself, not only plays against every member, but also play against myself, which does not make sense. So this continues on for a while. Yeah, so it makes up a huge long table. We don't like this. So what you could do is we need to basically eliminate the people that play themselves, and there's also ones where I play against someone, and that someone also is the first player and playing against me as well. So it has duplicates. So what we could do is filter these out if we want to, and in which case, if we do m1.name greater than m2.name, where m1 is referencing the member table, calling it m1, and m2 references the member table, whereas m2. Now we basically get more sensible. However, the only problem with this is the cross join. To get this up, it does first the cross join, and then filters out from there. So it's better to actually do an inner product. So inner product, we can join up tables where it turns true. So column from table 1, inner join table 2 on some condition between the two tables. So the on clause specifies the join condition. Some version of SQL, like DB2, and like the ones you pay for, usually those can usually figure out the on clause just from the where, if you have the exact same condition in the where clause. But some versions, some version of SQL doesn't have this, because you get what you pay for in the end. But but basically, some versions you don't need the on clause; it'll figure it out by itself. So the on clause could even use multiple set of conditions connected like before, like with and or. Could also use using function, but if you're using the using function, it has the exact same column name. And as I said, some SQL implementations constructed on clause right from the where clause, so you would just be able to put it into the where clause and it would do it up automatically, no problems at all. Overall, I find it better to have the on clause if you can, because it makes it a little more readable. So from here, it's basically using the where clause, we get the same way with using inner and our theta greater than equal to. Well, actually greater than. So instead, m1 player, m1.name, m2.name as player 2. For member, we're renaming member as m1. Inner join member as member 2, where m1.name is greater than m2.name, and it makes it a little more much more sensible, as in like I would only play against, in the first column, I'm only there for 6 times, then the other ones, then other times I'll be back to here. There's be definitely some that be just in there once or 0 times. So how many events does each member attend? So this query does not include members who attended no events. So queries ordered by events, only ordering the event query by events to do a little comparison later on. So you select m.name count. A references the attendance one. I'm just renaming this so that it makes it a little bit easier to type. M1. So M refers to member, A refers to attendance. So you find the name, the count of event attendance, as events attended, from member as member quest ID equals a.member, and grouped by m.name, ordered by events attended. And we see various names here. Some like 1, 2, 3, 4, 5, even some here with 8. This is all fictional, by the way. So there's also editor join. This would be helpful in cases where we want to include the members that attended no events at all. So a join that returns all rows for 1 or 2 of the tables, even when there's no corresponding value to it. In which case, for the rest of them, we just basically have null values. So left outer join, return all rows of the first table. Right outer join returns all the rows of the second table, and full outer join returns all the rows for each one, even if there's no connection between the two. Only left outer join is implemented in SQLite, unfortunately. So what are the names of Stack Club members and the attendance they and how many events they attended? So as contrast before, and name, same thing here, just instead we have a left enter join from member to attendance, and we group by the name, and so there's now 2 people now included in our list which attended no events. Apparently I'm very slack. Everybody getting this? Any questions? Yeah. A basically refers to the attendance table. So see here, I'm saying renaming attendance as A. So this way, basically telling us that creating an alias helps cut down on the typing and on the count. A.name. A basically refers to attendance. Realize that it does not execute it like this. It's written up as like this, but it actually first executes this first. And in SQL, it actually looks at this first and, okay, execute this first, figures that out, then groups it, then does a group or whatever. And so it figures things out, not by just going through like line by line, but as a whole. So it has to be processed as a whole. That's the reason why it only figures it out at the end where the semicolon. Yeah.
How do you join multiple columns?
A table?
Yeah,
2 tables?
Yes.
You mean 3 tables?
Yes.
So you would have another, say right here, you would have another left out join or whatever. So you keep on yeah, it keeps on going. So I believe it executes like this. Keeps on. So if it keeps on going like this, you keep on going until the very end of those joins. Any other questions? Okay. Natural join. Preferably not to use this, but this is join condition, letting the server decide the join conditions based off the same column names and types. So what are positions and duties of each Stack Club exec? You can do from Stack Club exec as E, or select E.name where E is exec, E.position where E is exec, and EP where EP is exec positions. So we select natural join. The join has the same position name, position column, and same data type. So it tries joining up on that. In which case it does it successfully here. And this basically details like duties of all the various positions. So it's a little bit more challenging, I think, but what are the email addresses and phone numbers of Stack Club execs who are in charge of attending at least one event, who's in charge or organizing at least one event? So this helps you get the overall syntax, overall layout of the database. So this is why I have the picture here, figuring out how to join up various tables together.
Yeah, I also see.
Yeah. Organizer?
Just
Um, oh, sorry, sorry, should be in charge of organizing. Sorry about that, Miss. This should be an or. So, charge of organizing at least one event. Should be of. Here. So first try to join up the two tables based off the organizer and then go from there. So try to break it down to simpler things and then just building off that and modifying. In this kind of question, table aliases are quite nice. Any questions?
Oh, it's just the first name. Yeah.
study, there's multiple people with the same name. So you don't want that happening, so because then you don't know what that refers to, because there's two people with the same name. Which one are you talking about? That goes into the design of the database.
Yeah, yeah.
Yep. But if the header joins, if it's on the left-hand side, it will keep that row. So if it doesn't have the corresponding entity.
Well, no, I didn't get the email. I found it online.
Just for the other columns,
Probably like 2 hours.
oh, because it's the header join. So if I do the header join, if I do the header.
Well, they make the decision. No, she wants to turn it into a crop, like, yeah. You don't want to be associated with that. Yeah. So you're not gonna make, yeah, you don't make money by asking for these things. So you think it's gonna end up changing your ideas and going like, charging everyone? Why do you read these
Is everybody done? Any more questions? Is everyone good? Okay, going on. So select distinct, exec.name, exec.email, exec.phone. From exec inner join event on exec quest ID is equal to event.organizer. What? No, don't need to group it. If you do distinct, it'll just eliminate the duplicates. This is pretty much doing the same thing as what a group by. But yeah.
Why do you use inner join instead of
inner join because otherwise, if you do an outer join, that would be include everybody from the exec, include everybody from the exec. Well, it joins up to the organizer, so it will not eliminate that. Will not eliminate the exec, those execs. So you just, if you do a left outer join, it will return all of the execs pretty much. What?
That makes sense because every event has an organizer. But if every event didn't have so have an organizer, that was no problem.
Everybody good? Any questions? Okay, subqueries. Subqueries are queries that are contained in other queries. These are done up in round brackets. There's basically two types of subqueries, non-correlated and correlated. Non-correlated queries, best thought of, can be run by itself. Correlated queries basically reference to the outer query. So it basically runs on every row. So it has to be run concurrently with every run of the outer query. So they're very dependent. So for each row on your outer query, that inner subquery, correlated subquery, has to run. So it repeats many queries. Non-correlated, it's any valid, any non-correlated basically can be executed by itself and give you a result, including an empty set. These have to be included in the round brackets and can be found in like in the from clause, in the where clause, or having clause. From clause basically brings it up and makes it look like another table that you could join or whatever you want. And the where clause basically helps you on conditions, like was shown before. Like if something was in that subquery, it could be in the where clause. Same thing with in the having clause, which is pretty much the exact same thing as where, but with aggregate functions. So, for instance, what staff club execs are in charge of making posters? So, if we do is select e.name and e.position from exec, where exec is e, where quest e.quest ID is in this select poster from event. So, in which case, we don't really need to do a join here. Many ways you could do joins or subqueries. It's preferably actually better to do joins. For all implementation of it makes it easier to process of what's the best way. But you can do subqueries, and sometimes you kind of need to do subqueries to build up the result query that you want. So correlated subqueries, it makes reference to the outer query and executing for every candidate row. This could be appear in like the select clause, in the where clause, or having clause. In the select clause, it has to be that the resulting query should have to be result or return only one result if it's in the select clause. And so, what majors are the current SEC Club execs rolled in? So, the SEC Club members has information on majors, but exec has doesn't have information on exec. Doesn't have that information on execs. So we need to basically manipulate the member member table and the exec table. So if we do select name position, and we do a correlated query right here, or select faculty from member as m, where m dot query m dot quest name is a reference to e dot quest name, where e is exec right here as faculty, and same thing with major. And from here, it's basically gives all the ones that are also exec members that are also stack level execs that are also members, and gives out their faculty and major. Notice that some are not members. They didn't pay the $2, so it's null right here for some of them. But for the ones that are actually in there, their faculty and majors is done up. Any questions? Yeah.
What do you mean the as faculty?
That one, basically just to name it so it doesn't have that whole select. Instead of having this as a name, it just has this as a name. If I didn't say that, then it'll have this whole string here, right there, and it's be really long and yeah, I named it just to make it easier to read. And same thing here. Remember, this is all of this is in the select clause. Any questions? Good. It's almost lunchtime. Correlated versus non-correlated. Correlated is dependent on the outer query. Non-correlated is not. Correlated queries is executed concurrently with the outer query, so it has, for every row, it pretty much has to check each one and find out what's happening. So it can be potentially really expensive if the outer query has a lot of rows. That means you have to do so many other additional queries at the back end. In general, for execution of speed, in general, correlated queries takes the longest one because you have to do queries on queries several times. Non-correlated queries, you could just SQL just does once and keeps the table in there for everything you need to reference. And joins is the best one because it has syntax available like for primary keys and foreign keys, so it helps reference and try to join up really easy. So in general, if you can, do a join. If not, try a non-correlated subquery. And if you really need to, do a correlated query. And if your data is not that big, like for us, like who cares? But so where can a non-correlated subquery be placed? There's 3 places. From?
Having, where, from?
Yeah. From, where, having. And what about the correlated subquery? Okay, select. Where else? No, that's only specifying columns.
Select where
Yeah. So the only difference is non-correlated from, and correlated could be in select. Using a non-correlated query, what are the names, locations, and descriptions of events that serve pizza? So, like, basically try to break this problem down to smaller pieces. Like, what are the events that serve pizza? And only retrieve the values from the table event that were for the event that name matches those values. This one's a little bit more difficult, so don't be afraid to ask questions or attempt it and not succeed, but I'll be right back. I'm going to check to see if it's here. If you have any questions, Any questions?
Basically does explain Go back. So the event. No, that's not right. That's not even the one. It's right here. Expenses. Look for here. So expenses. There's name. Doesn't have the column name. So go to event. VX that event.
I don't even need the EX.
Well, potentially, yeah.
you have select? Yeah, there it is. Go ahead, sir. Oh, because, yeah, most of us. Oh, create this? Well, you could do that by table.
Yeah, I did this. And then,
Yeah, if you know more.
how do you enter data? So that way.
You do insert into table, insert into do some syntax for inserting data, and then you just insert that basically executes query and inserts data to a table.
You can just like.
Potentially, if you want to, if you have a CSV file, you could,
We can do it.
yeah, you can import. You can import from a CSV
Yes, we.
file.
Okay, cool. Okay.
If you have a big database.
Okay.
Any questions? I'm hoping the food comes up pretty soon. I'm hungry.
Is the food here?
Should be here pretty soon. That's what they're getting it for. Yeah. Yeah, if you don't know, we're getting Subway. Cold cuts, I think beef and veggie. Any questions? Are you guys done? Okay. Everybody done? Any more questions? We're going to finish this up and then we're going to break for lunch. Well, I don't want to do more until we get lunch. So breaking up into a smaller questions. Select event from expenses where pizza. So that basically tells us what events has pizza. And then we want to only retrieve the values, the columns that are according to those values. So we select name, location, and description from event where name is in this subquery, where select event from expenses, where expenses pizza, and comes up to this query here, this result here. I just forgot to put in those location and description entries. Everybody understand? Alternatively, we could also use using a join. So if we do select e.name, location, e.description, from select event from expenses, where expenses pizza, as inner join our event. We're onto this event, expenses event equals e.name. This also does gives the exact same results. So there's multiple ways of doing the same query. There's no real preference to either or. So as I said, the relational engine should catch this and figure out which one's the best way of doing it. So good. This is for the next operation. I think this is a good time to take a break, and hopefully the sub should be here by now. Only problem is, yeah, it's how do we make sure nobody steals our stuff? It should be in MC Comfy, so I'm gonna check there. Okay. Who's ready? Who's ready?
Ready. Yo, do this question.
I wanted to make a sexist joke, but how different. Asking for
Yeah, it was
Oh, is that? Yeah, because I did have something like 5,000 when that happened.
Okay. We should probably grab the laptop. No. You?
I don't know how much I did.
Are you not getting that?
Just keep going.
Oh, are you leaving?
isn't that what she told you?
Oh yeah,
Oh, a friend.
like she was saying, Frank, which is her boyfriend, is supposed to be here, but
Good way of spending afternoon.
Do you want to eat? How are you feeling so far?
It is fine. I find this one very useful. I have used them, but none of the platform on the Microsoft the Access function. We have slightly different user interface, and this. But when I enter there, I use select from group order and simple things. I didn't know how you join. I find joining two charts is very useful in brain. Wow, recurring could be that long.
So that's because you do multiple circles, lines,
So when we do simple information, maybe only about 4 lines, 5 lines, and it's hard to imagine how long the lines could be.
well, that was it. Later on, we do the case expressions, where, you know, it's a bit like if statements. So case, case when something else happens, then this, return this result, and so on. So you can have kind of basic questions to change things around.
The basic function you mentioned is pretty much like the C language. It has
Yeah,
case
so,
file.
yeah. It's very much like,
You can also use SQL.
so, I'm not sure if this syntax is up to say. Typically, it's going to be
Actually, this is a little simpler than C and C++. We spend a whole semester learning the basics of the language, C language. It is very convenient.
There's one nice thing about it. It's very high level, but folks really use it. So definitely this is why we try to substitute for all. That uses SQL because you don't have to really have to do basically code. Yeah, folks. It's not a okay fun fact. It's basically getting that right. So if you need to understand that we're able to understand with this information, store this, so it stores it into the web, saves it, and then traces it.
So the search function from basically the underlying principle is the SQL.
Well, the very last, I would say that the browser one is so it helps find it what's happening, and so it stores all the important information.
It is like we search for a keyword and it returns several entries that is connected to our keyword. It's like the where clause we learn.
Probably just very simple. Doesn't that manufacturing that deal? Create your own separate database which would have 20 times less. Just connect this up with you can actually use C cruiser. There's show some icon. And basically forward the query forward the information activity and tell it to go through this method or this function and like that. Yeah, instead of having to reinvent okay, just call this up.
Database language is different from those compiling
Yes,
ones.
it has no sign.
I'm sorry?
It has no sign. There's no X equals 5. That doesn't exist. It took me a while to understand that. If you go to your website, Make sure nothing gets stolen. Okay.
So we can come back now?
Yeah.
No, it's because we only have an hour left.
I know, yeah.
Going a bit slower than expected. What? Yeah, I didn't realize this would go straight to the
Do you issue like 7 and 5? So like you don't like to go back.
Well, the thing was last time we tried this, we went to see a lead, he was in there, and took those out of home, and
Maybe it's more comfortable.
yeah. Well, we've had a lot more like leftovers now.
Really?
The last term, yeah. Okay.
I've heard biomedical
Okay, everybody ready to go? Okay. Set operations related to SQL. These are a combination of two rows, combination of rows from two different tables into one result set. So we the tables or result sets of have to have the same number of columns and the same data types. So, like, if you're basically have less for one of the tables, could sometimes use a null inside of a select operation, in which case it'd still be able to join up, but it has to have the same number of rows. Have the same number of columns for both tables. So we could do a union for tables A and B, combines the rows for A and B into one result set. Intersection is basically where one row is equivalent to the is also in the second table. Then it appears in the result set. The difference is basically subtraction of one set minus the other set. So here's how to do a union operator. The square brackets there, that's just indication that the all is optional. So additional of one result set to another. So for instance here, table A and table B with x1, y2, z3, and a8, y2, z3 results in basically this table here, which has x1, y2, because y2 is in both of them, so it just includes the one of them. The same thing with the z3. There's also z3 here, so it just returns 1. So the resultant table here has just one more row than either or of these. Union all keeps all of the operators for all of them, so including duplicates. So if I used union all here, I would have a table with 6 rows. So as I see here, suppose, now let's give an example. Suppose you want to contact everyone involved in the stats club, execs and members. Members, some execs that are not members. So what are the names, email addresses, and phone numbers, if we have them, of all of execs and members? So what we do here is select name, email, and since a member does not have a phone number, we just say null as phone. From member, union, select name, email, phone from exec. So it gives us the results of this. And returns any, and eliminates. And notice here, since one of them is null, and this one here is, since I have my fake number up there, yeah, that's basically saying, since those are slightly different, it still considers them distinct, so it keeps both of them in there. Intersection, now it basically runs a bit like union, but instead returns only the tuples that it has in common between the two. So yeah, so basically x1 is not in B1, sorry, B, so we take that out. We'll have our y2 and z3 are in B, so it'll the intersection will return that result. So for instance here, what stats club execs have also signed up as members? So if we do name quest ID from member, intersection of select name quest ID from exec, and this gives us the results here. These are all the execs that also are stat club members. Any questions? Good. Difference operator, it's used except. Returns the first set minus the second set. Minus anything it has in common with the other. If you use all, it basically goes to 1-to-1. So if there's duplicates, so say if there's several in A, several tuples, several rows that are exactly the same in A, and there's only one B, if you do accept all, it will just eliminate one. Except basically just uses the minus, the set theory kind of version of minus. The optional all uses bag semantics. As I said, like, if it has duplicates in A, and just one in B, it'll just eliminate that one. Yeah. So as you see here, X1, there's 2 Z3s here. It has only one Z3 here. So that Z3 eliminates one of these, and therefore it keeps just the rest of these. This one eliminates that one. Yep.
Would B minus A just be
What? B minus. Well, there's still the A8 that's not an A. But yeah, pretty much. Like, except for the A8, yeah, it would be. Any other questions? Okay. So, what Stat Club members are not execs? So, select name, request ID from member, and we're taken away from, so exec, select name, request ID from exec, and we get all the members that are not execs at all. With clause, this basically helps create a non-correlated query that makes it look like a table. This helps in readability purposes. So we can create with subquery name and the square brackets there, just saying that's optional. But if you include the column names, type it in there in round brackets, then as your select query, select non-correlated query, and so on. Then you do a comma here, next query. This helps out readability purposes, so it helps, especially it helps out quite considerably if you have doing multiple subqueries. If you just have it like this, the actual select statement makes it look like a very simple query. Can make it look like a simple query. So suppose we're doing a report for MassDoc detailing events, budgets, and expenses. So with cost, event, expenses as a select expense, sum, price from expenses grouped by event. So then we basically select event name, E's event, event type, where E's event, E budget, and C's cost expenses, where that references that subquery right there. From event as E, interjoin the cost subquery we're having detailed up here on the name equals the cost of event. So this basically tells us if we're over budget, under budget, etc. Any questions? Yeah.
Do you mind going back a slide?
With clause?
I missed the clause.
Okay. With subquery name, the square brackets there just means that it's optional. So when you're actually typing this out, don't include square brackets. But if you want to include column names, do it in round brackets, then type out various column names that you want, and then I'll name these. Then I'll name this the result set from this query to those column names. Good. Any other questions? Okay. Now let's do a little bit of a hard quiz. This one's kind of hard, so don't be too frustrated with it. MassDoc provides a maximum cap on social events based off a formula. What's the max cap for social expenses for Stats Club? So it's max of 250 or the number of MassDoc members times 5 plus the membership fee, which is 7. So it basically goes down to max of 250 times number of MassDoc members times 7. So first try to break it down to what are total expenses for a social expense and then max budget. Just try to work on it a bit. I thought give one really hard question, so but don't be too frustrated with it. So first, try to find the number of, first try to do a subquery, number of MassDoc members. So basically, the MassDoc member is basically members that are in the Faculty of Math. And yeah, so this here should be 7. They're up here. So times by 7. So basically, where social defenses are, find a number of find a count of MassDoc members, or members that are in the Faculty of Math, times 7. That's one part of it, and then just try to find the maximum of that, max of that, and 250.
Sorry, what's the cutoff part, like on the right there? 5 plus.
5 plus membership fee, which is $2. So think of this as 7.
Yeah. So 7 times mass.
Yeah. Which MassDoc members is members that are in the Faculty of Math. If you have any questions, we're pretty close to the end, so. Yeah, so remember, break the problem with smaller parts, and if you have any questions, raise your hand. What?
And that number is 7. That's, no, you just need to find the maximum value. Yeah. So we basically how to figure that out. Because but these queries have to start this way. What did you whether it say you do want to do maximum. So what about the unit to columns? Like that number?
What is the mean?
This is now
Why is it event responses for everyday practice?
this here.
Why do you have this thing?
Oh, because how do you reference that column?
So it's saying, it's making a new table called costs with 2 columns, event and expenses.
Okay.
So that later in the call you can, you can call, you can call it. So it's saying this is made up of what's the output from this column. And then the selection of columns.
Yeah.
Otherwise,
Yeah.
so then there's like some columns.
No, haven't.
And then you join it with, I guess,
Yeah, the event
the event
table such that.
the name becomes,
No, not becomes, it's the number, so it's when the condition is
right, yeah. So then join the event with the cost table.
So that will just give us more columns. We take 3.
Like the connection and all that, but that's
Yeah, it's pretty well done.
No, but why is it like it's an extra that we can what we get?
Yeah,
And why do we even
like
ask
our,
Oh, because we just,
connect to a database, essentially.
because we have a condition there, right?
Yeah.
And also that's,
Is it because like every every practice has already SQL and
No,
like
but.
Because they think cost maybe isn't actually a table, maybe cost is
it is. That's what we generate using that select.
Have very customers modules and
Yeah.
packages. It just calls up and then it turns that data.
It's just weird that.
SQL is a lot
So
more
here,
ambitious than
event and expenses.
yeah.
Oh, that's better.
You're saying those are the names of the pairs, right? Yeah, they are.
Your question?
But then again, they are as well the names of the different
Yeah.
which is very confusing.
Yeah.
Yeah, what's,
Oh, because event is also a table.
So yeah,
And it has 3 or maybe more columns.
right.
Name, type, and
Okay, so,
budget.
yeah.
So when it's saying select those columns, plus the expenses, plus the cost table, and join those.
well, where's it
So
say
then
exactly?
I think that works, and then you have a table, which has the
So it
cost,
doesn't really know where to get it unless it's full stress.
plus your type.
Yeah. No, the thing that confused me is that the first line, they have event and expenses as the main of the columns. The new one tweak is
Yeah.
and they doesn't know what to do to the tables that we have.
It only references the size of it.
You know what I'm saying? Like,
Yeah.
if we call them differently, we have to manage it.
Yeah,
Because
Yeah,
that reference to itself.
and then you have as the output, you have a table with 4 columns. Alright.
Sorry? No, just stretching.
Yeah. Good. Well, that's right here. Okay, yeah, okay, so remember all these that have none? So you need to replace that's everything. Not sure if that means the actual specification. Yeah, that's it. Yeah. Yeah, true. Well, it's not as efficient. So, yeah, just basically want something like that. Just like instead of so that basically that's okay, you have something's here. Oh, I think I added one thing. That's the reason why. I actually changed the database and.
Oh, okay, okay.
No problem. Oh, yeah.
No, that's something that's okay. Yeah, you just basically don't have very members and socials. I'm going to go on to the next one. Yeah, this is challenging, but I'm hoping that you enjoyed trying to figure this out. So, breaking up the smaller problems. So, what is the total expenses for social, and what events are social? Then from here, find out what's the max cap for the social expenses. What's the end result of this formula? Yeah, I should have actually brought that up beforehand. Sorry. So first, for social expenses, we need to find some expenses, filter it non-social. So first, find out which social events are social. What's the total social expenses? So sum of the price from expenses, where event is an event where the type is social, and we get this number here. We could also do it through joins, where select expense.price from event as inner joined expenses as exp on the event name equals event expense.event, where type equals social, gives us the exact same thing here. Then we have one half the problem solved. And the final result would look like this here, something like this here. And so we need to calculate the formula for this. What's the number of social math members that are in effect the math? So select count star from member where faculty equals math. We get 33. So what's the result of this formula? Basically count star times 7. What's the maximum of this number and 250? And we could do this here and gives us out, well, what's the maximum of this here. So select max count star times 7 and comma 250. Max has an interesting thing that you could have multiple columns and actually tries to find the maximum of all of them. So, so if I have a number here, 250, and this here, it'll try to calculate this out, and if there's only one entry, find the maximum of these two. So joining up all together, so with social cost expense, as we're here. Then we just select expense, budget, budget minus expense. From social, cross join social budget, and we get our expense to our budget is 250, and budget minus expense is 3.7. We have basically over $30 in the black. So everybody understand this? Look at it for a bit. You can understand why, like joining up, how SQL can make it bigger and bigger. Like if you make more complicated questions, your queries can make it quite a bit bigger. That's actually one of the nice things about width. If you do the width here, you can make a simple table from this query here, same thing here, and then your actual
query that's done out. It makes it look a lot nicer and easy to read. If you didn't do that, you have to put this here, this whole subquery into here, and this whole subquery into here, and try to figure out what's going on. You guys want to look at that for a bit? Sure. Yeah, this is a really hard one. I wanted something challenging, like really challenging. So,
What
yeah.
do you added the cross join?
What?
Like the last.
It could be inner join. Doesn't really matter. It's 1-to-1. So
Okay.
you could have inner join, outer join, whatever you want. Just it wouldn't really matter at this point. So any questions? Good. Okay, go on. Case expressions. This is, you can think of it almost like a series of if-else statements, or if you're familiar with C, like there is, I think, switch operations and case operations where this is true. So say case, if you have a column in here, square bracket just means it's optional. If you have a column, then you just basically have a value here for that the column could be. Then if that's executed, if that's true, then that returns that result. If you don't have a column here, then you have a condition right here. If that turns true, then return that result. And same thing here, and here, and at the very end, you could have an else statement and give a result. Remember, at the very end of it, you have an end. This could basically put into various places, like into select clause, I think, also in the where clause, a few other and a few other places. The result can be of any data type, but it has to be the same data type because it is going in the same column. Case expressions formed by case expressions could also be performed inside of aggregate functions, in which case it applies a value to that aggregation function. I can never plan. It's a long day. Expressions within aggregate functions allow us to do some cost averages of particular occurrences. So suppose we're preparing a report for MASOC, and we could basically perform the query we had before, but instead when it's over expense, we could do it like, we could basically check, okay, when the cost is black, then we say, sorry, when the cost is our expense is over our budget, which means it's negative, then we're over budget, and it could also give like a little warning. So case when budget minus expenses is negative, then over budget, else null, and end, that ends that whole case expression in the select clause and as a warning. So this basically creates a little warning to saying if one event is over expense. So not half an hour left. Do you want me to go through this, or just continue on, like explain how to do this. Do you want to try this? Do you guys want to try this quiz?
Can you finish the material by time?
It's near the end, but at the same time, it's like not. I only have half an hour, so I'll just continue on then. So, suppose we're interested in healthiness of food. What's the average of our healthiness according to the score? So, if we do select average of our case, where expense is in donuts, pop, or fries, then -2. If expense in pizza or cookies, then -1. If it's coffee, 0. Water or meals, then 2. If it's veggie platter, then 3. Then finish it up our average function and saying its average score from expenses. So it basically for every row in here, it checks to see it's in here. If so, then takes that number, puts it back, and then it does the average of all those. In which case, the average of minus 0.75. Apparently, we're not healthy. Next, order by clause rearranges rows according to a tuple of columns. So we select our column list from some table, then we order by our sum column 1 to n. Could be ascending or descending. Ascending is the default, but we could also describe descending. So what's the membership list ordered by name? So if we select name from member, order by name, we start off with the A's, then keep on going until the V at the very end. Limit clause, we restrict the result set to the first n rows. So select from table, limit the number of rows. Could also even do offsets. For instance, limit number of rows, offset a row number. Just input numbers instead of these string of letters. So it could be limit 10, offset 5. So what's the first 10 members ordered by name? So select name from member ordered by our name and limit 10. And what's the top highest priced items and expenses? Select expense price from expenses ordered by price and limit by 10. And here's everything. These cookies are basically because they're for different events, so it doesn't eliminate the duplicates. We can eliminate the duplicates if we put distinct up here. So topics not covered is how to create a database, creating tables, constraints, indices, views, how to insert, delete, alter table. Here's some of the learning, how I learned some things and some references. I learned a lot of SQL through Learning SQL, which details more along the lines of MySQL. There's also CS database courses like 338, and also for CS majors, 348. There's also Coursera courses like Introduction to Databases, Getting and Cleaning Data. Any other questions? Yeah. What? Yeah. I'm not sure where it's from. I forget now exactly. But it details more along the lines of like connecting through R and all that stuff. But yeah. What time's it now? Okay, apparently went a little bit quicker. Have also additional practice questions if you want, or do Or if you want, I could do one on how to use SQL with R. I also have one for Python as well. Do you want to go this or some practice questions? Practice questions? Okay, this here using SQL with R is also on the wiki, just additional pages. Spez it. There it is. Okay. So, what events have dates specified? Like which ones are not null? So, which events have dates where it's not null? Yeah. Would read books. There's also a book online. I don't know. Well, the thing is, this workshops are very tiring and very expensive, and I need to do schoolwork. So. Yeah, so I'm loaded, but yeah. Yeah. Yeah, if you want to, this I'm basically specifying along the lines of how to query, not like how to create, not how to actually create the database. Well, it depends on if you want to create the data, like what angle you want to go to. If you want to, like, I specify more on queries because that's how like statisticians would use it. But yeah, like if you want to basically create your own database, you have to learn it by yourself. But I do on the wiki, I do have some references, like some
Do you have
guides.
references for Python with SQL?
Yeah, that's another one was planning on going to, but I don't think I have enough time.
Yeah, I don't think you know.
Yeah, if do you know Python?
Yes.
On the GitHub,
Okay.
I have I use.
You have notebooks. I've seen them. I've
Yeah.
seen them before.
Yeah, one of them was with using SQL with Python.
Oh, okay. Yeah. I think I saw that. Okay, I'll check it out.
Yeah, I haven't. Like for instance, if you want to use using SQL R, it's right here.
Oh, that's nice.
Yeah, so and common SQL statements. So query, basic query projection. No, this is basically a review of how to query, and so near the end, here's how to create a table. You can table query strings, primary key, creating view, deleting view, so like just very basic stuff. No problem. Yes. Everybody done? Any questions? Okay, good to go on. Select name, start time from event where start time is not null. That's one way of doing it. There's multiple ways of doing this. So in which case, the result. Next, what events have dates specified? Which events don't have dates specified? Okay. This one should be actually pretty easy. It's pretty much just the opposite of what we had before. Yeah. Has everybody got it? So, as I said, now this now select name from event where start time is null. Oh, actually, I messed up here. This actually should also see comma start time. This is not quite right, but so what stack club members are in stats, axi, or CS? Recall the in predicate operator. So, what stack club members are in one of those departments? Everybody finished? Any questions? No? So select name from member where major in stats, axi, or CS. Notice the round bracket. And yeah. Give us all these guys here. What are the stats club exec positions? And avoid duplications of positions. Yep.
Can you put the answer to the last question?
What?
Can you put the answer to the last question?
Answer to the last question. Okay, insert. See? Good now? Okay. So, everybody ready? Done? So select distinct position from exec position. You could also potentially do it from execs, but if there's an exec corresponding to that position, you would leave that would be left out. So this is a little bit better because it definitely keeps all the positions. Are we on? See that? Any questions? Okay. How many different Stack Club exec positions are there? So now we're basically doing a count. Yeah, remember that we can use distinct within arrogant functions. Everybody finished? Good. So select count distinct position as what we want. Just want to name it as something from exact positions, and we get 5 different distinct positions. And that's it.